Hello, everyone, and welcome to today's webinar, Beyond Maintenance Types by Ahmed Kotb. I'm Nick Rush, the media specialist at Mobius Connect, and I'll be your moderator for today's session. This presentation is a part of Mobius Connect's Week of Webinar series. WOW is a free collection of one-hour presentations delivered by industry practitioners from all around the world, all happening this week. You can earn continuing education credits for tuning in, so be sure to attend as many presentations as you would like. This webinar is being recorded and you will be emailed a link with access to the on-demand version. Also, you can anonymously submit your questions through the session by using the question panel on your screen. At the end of the presentation, Ahmed will answer as many questions, so be sure to get those in. So without further ado, Ahmed, I will go ahead and pass the presentation over to you.
Thank you for the introduction and welcome everyone to my webinar. This is Ahmed Kotb. I am a mechanical engineer, graduated 1985 from Cairo University. I am a certified maintenance reliability professional, asset reliability practitioner, and an approved Mobius Institute instructor. Most of my experience in the oil and gas industry, working with international leaders like Shell, MPP, and Total, and I led more than 40 shutdowns and turnarounds planning and scheduling, and I participated in mega projects, and I headed and led many teams during my experience, and I was implementing CMMS and asset management systems in several companies, and I led one of the largest implementation projects in the world in my previous company. And I'm a published author on reliabilityconnector.com. I am a speaker. I spoke in major conferences around the world, and I got awards from my speaking participations, like the one I got from the SMRP in 2020. I am also a trainer. I conduct several courses in maintenance, reliability, and shutdowns, turnarounds, and asset management, RCM, and so on. I received several appreciations, and I have many certificates of appreciations, and I have more total certificates, more than 335 certificates from different sources in participation in conferences, in training, in other activities. So let's go to our subject today, which is the beyond maintenance types. I think this subject will be very interesting, very rich, and very important as well for all the maintenance professionals. So for the agenda, why I chose this subject, this number one. Number two, we will be addressing the common maintenance misconceptions, and we'll give a practical guidance from standards and best practices. We will speak about the main subject was beyond maintenance types. It's not just about maintenance types. And what is built on maintenance types actually, let's make it more serious, and the cascading impact of maintenance misconceptions. Would see the impact of these misconceptions on the different levels, and we'll give at the end a key message to our audience. So why did I choose this subject? I choose this subject really because from my experience as instructor and trainer and from my discussions during the courses, the conferences, and so on, I discovered that there is a big knowledge gap in the maintenance professionals. Like when I ask some basic questions, I don't get the proper answer in most of the cases. Though the people were asked are maintenance professionals, including maintenance managers. Questions like what? Like, for example, what's maintenance? Very simple question and should be known by all the maintenance professionals. That's your profession, so you should know what are you doing. No, I don't get the answer. What are the maintenance types? This is very basic, and we'll be covering this today, inshallah. Why do we do maintenance? Why we do maintenance? Most of the maintenance professionals don't know actually why we do maintenance. Okay, which type of maintenance we should do with which type of failure? Such a question, no answer. What is the feasibility criteria for applying preventive maintenance? When I should apply preventive maintenance? When should I apply condition-based maintenance or predictive maintenance? What's failure? What is the definition of the failure? What is reliability and how do we measure it? What is the maintainability? How do we measure maintainability? What is availability and how do we measure it? Where can we find the assets down time? What is the difference between maintenance and reliability? What is the relation between maintenance and reliability? The answers on these questions will be just stories, or somebody will tell you, everyone will tell you what he believes, what he thinks, what he understands, things like this. There is no standard reference, there is no solid answer that shows that there is knowledge of the subject. So I've noticed many inaccurate or misleading maintenance posts as well on LinkedIn, despite assumed good intentions of these posts, but they are, most of them, 90% at least of the posts are wrong. Some incorrect posts come from certified professionals. That's make it very sad that most or in many cases, the wrong posts, the wrong information about maintenance or the misconception come from certified bodies. Yani, that's very strange. And there are countless of such posts coming every day. There is a feed of posts about maintenance and reliability, and in many cases, there is no accuracy at all. So we will see some examples of such posts in our webinar today. So what are the reasons for such misconceptions that are spread among the maintenance professionals? So number one is the limited awareness of standards. These people, they didn't use standards, that's why they are believing or thinking or spreading wrong information about the maintenance. Second thing is a lack of unified references. They are only depending on personal or company-specific practices over global standards. And the third reason, over-reliance on opinions. Everyone is referring to his own opinion, regardless of standard or recognized reference or whatever. So they prefer their opinions over the standards or the references. So this causes inconsistency, of course. And misinterpretation of terminology. They don't know what is the right definitions of the maintenance types. They don't know, for example, what's condition-based maintenance and when it will be used and what's the definition. They don't know. Insufficient training. This is because the lack of knowledge is because of insufficient training. These organizations, they don't give them training. They don't educate themselves as well. So this knowledge gap is there. So the very serious reason is the dependence on AI. Nowadays, because there is AI and it helps everybody to make posts, everyone need to post some posts on the media to be popular or to be known or recognized or whatever. And they don't care about the accuracy, they care about how many posts I post per day. So that's very dangerous because the AI doesn't have experience at all and it doesn't have any access to standards or recognized references. That's why it's giving you misleading information. And unfortunately, these people who are posting such posts on their LinkedIn, they take it as it is and they put it there without checking its validity or accuracy, whatever. They just take the post as it is and publish it, and of course it is full or it has many of misconceptions or wrong information about maintenance. This is a big reason for such spreading of misconceptions. The other reason is desire for popularity. People want to be popular, they need to be known. So they want just to publish, they want to post. So they just spread wrong information without checking and without taking care of what they are writing about maintenance or publishing. Also, the desire to appear different. Some professionals may champion unconventional ideas to look different. I need to give a new idea in the field, so they try to give ideas which maybe not matching the standards, and these ideas will be odd and to grab attention. Okay. Number 9, which is the social media amplification. Of course, social media is helping this spreading of the wrong information through the posts and videos and conferences, things like that. And there are wrong information within these media. So this is very dangerous. It needs to be checked and verified before you accept or understand any of these. So we will address the common maintenance conception. Of course, we can't, during this very limited time, cover everything, but we will try to cover here the most important or a few ones that most popular or most spreading, and see what's the correct idea about everyone. So the first one, the first misconception is there is no standard definition for maintenance. People can define maintenance as they like. When you check the net, when you check the LinkedIn, the media, the posts, you will find everyone is posting and defining maintenance as he likes, without reference to any standard or maintenance standard or in any recognized reference. For example, what we see now is a definition for maintenance, which is incorrect definition for the maintenance. It has some right parts and it doesn't have all the correct information, and it's not matching with the standard definition. And what, as you can see here, down here, that you can see how many people give likes about this. This post was about total productive maintenance. It was a presentation at the first slide, or one of the first slides was the definition of the maintenance, and the definition is not matching, but the post got 203 likes until I've seen it, and it has 26 reposts, means that it's spreading this message widely, which is containing wrong information, as we can see here, and we will see what is the correct definition when we come to the correct definition. Okay. Another one, okay, another definition of the maintenance is just describing maintenance, not defining the maintenance as should be from the standard. Even AI, if you go to the AI and ask what is maintenance, it will give you a definition which is not matching the standard definition, because as I said before, the AI doesn't have any access to the standards or to the references. And one called Maintenance 101 made a post on the LinkedIn, for example. It's saying you, a maintenance professional, are at a party with guests. They ask you, what do you do for a living? How do you explain what you do? So everyone should say, I'm doing maintenance. Maintenance is such, whatever. So what you got on this, in response to this post, as you can see here, everyone is telling a story about maintenance. There's nothing referring to a standard definition of maintenance as should be. As we are all professionals in maintenance, we should know the standard definition of maintenance. Here, you didn't find any standard definition of maintenance. That's why I commented on this post that's why there is a standard definition for maintenance, and unfortunately, most of the maintenance professionals don't memorize it, and hence they tell stories when they are asked these questions or this question, as you can see here. And ironically, the guy who made the post, and he's supposed to be teaching people maintenance 101, teaching people about maintenance. He himself didn't know what is the definition of maintenance, and he said, I appreciate your perspective. It's valuable, or it's valuable to align on definitions. If you don't mind, could you share the standard definition you have in mind? So he himself, he doesn't know what is the standard definition. So no, there is standard, of course, for the maintenance, and the standard has a terminology, it has a definition. This standard, for example, the maintenance terminology EN 13306, which we will be speaking about in this webinar, it has the terminology about the maintenance and maintenance types, and there are many other maintenance standards about the documents, for example, for maintenance and maintenance key performance indicators, maintenance processes, and the associated indicators. Everyone is looking to the maintenance from his point of view, but we should refer to a common definition of the maintenance from the standard, so we have a consistent terminology across the the field of maintenance. So most of or many of maintenance professionals, they didn't see such standards, though they are very important for their work. So what is maintenance according to a standard definition? So the old definition of maintenance in 1993 by the British standard was what? The combination of all technical and associated administrative actions intended to retain an item in or restore it to a state in which it can perform its required function. That is the old definition. Now, the new definition, and in this 2017, and this tells you that the standard is keep evolving, and it is always updated. It's not freeze. So you have to update yourself constantly with the updates of the standard to see what is the latest update, what is the latest definitions and terminology in the standards. Here it says what? Combination of all technical, administrative, and managerial actions during the life cycle of an item intended to retain it in or restore it to a state in which it can perform its required function. What is the importance of the definition? Definition is a short paragraph including all the meanings about what you are defining or what they are defining, and it is a reference for all of the people working in this profession to refer to it to see what it includes. So from this definition, we can know many things. Like, for example, maintenance is not only the technical work. It says here technical and associated administrative, technical, administrative, and managerial actions. So non-technical, such as what? Such as spare parts, purchasing, for example, contracting, budgeting, training, HR, all of these are non-technical and they are impacting the maintenance work. Okay, so maintenance is during the asset life cycle, not only the operation phase. This has been added to the new definition for the standard when it says here during the life cycle of an item. Didn't say during operation only, as many engineers or many professionals think that the maintenance is only in the operation phase. No, it says during the life cycle means from the beginning, from the design phase until the disposal of the asset. Maintenance is needed for what? To keep the reliability as designed or restore it when it is degraded. So retain it in or restore it to. Retain it in, keep it on the reliability level, the assets in, or restore it to the desired or the designed asset reliability as should be. From this, we know that the relation between maintenance and reliability is what? Is that the maintenance is a reliability tool, okay? Maintenance can't increase, the maintenance is a reliability tool to preserve the reliability of the asset or to restore it back to the level as it is. So reliability has many tools. One of them is maintenance. Maintenance can't increase the reliability, only keep it or restore it because reliability is inherited from design. Okay, so whatever we do in maintenance, we can't increase the reliability beyond the design level of the reliability of that asset. But maintenance can increase the reliability from the low level when it's degraded to the desired or the designed level, and this is the maximum. Okay, the main concern is the asset function, not the asset life, because to perform which it can to state in which it can perform its required function to a state in which it can perform its required function. So we are getting buying this asset to do a certain function. That's why we are maintaining this asset to keep doing the function. And this is a copy paste of the definition from the standard. Okay, so the misconception number 2 is there is no standard maintenance classification. There are on the net, you can see many classifications for the maintenance, as you can see here. I'll give you just very few examples. The net or the LinkedIn or is full of wrong classifications of the maintenance, and you can see here one of the posts says, and it is translated from Arabic, by the way, by the LinkedIn itself. Maintenance divisions are not fixed. There is no specific law because they can simply be divided from many angles. So let's talk whatever about famous divisions. So the person who wrote this, he is thinking that maintenance can be classified anyway from many point of views, and not referring to the standard classification. And we'll see this later on. Okay, the next misconception is that the maintenance divisions or classifications or types are many. You can see the same person who posted on the previous slide. He said, let's agree that maintenance divisions are many. And they depend on the way of thinking and your point of view. So everyone can classify maintenance as he likes, from his point of view, as he likes, as he thinks. Okay, and he gave here some classifications for the maintenance, like predictive maintenance, risk-based maintenance, reliability-centered maintenance, total productive maintenance, total productive maintenance, and all of these. These are not classifications of maintenance. Reliability-centered maintenance is not a classification. Total productive maintenance is not a classification of maintenance. Run maintenance, shutdown maintenance, these are not standard classifications at all. And here, the maintenance divisions classification and types are many, listing non-standard divisions types of maintenance, such as risk-based maintenance, RCM, and so on. Someone stated that the maintenance has 9 types, as you can see here, 9 types of maintenance, and he includes in the types of maintenance failure finding and risk-based, and they are not standard types of maintenance. Here, another one, he said 6 types of maintenance. This is 9 types. This is 6 types. This is some others. And here again, for the same post I mentioned before, that has 26 reposts, types of maintenance. Preventive maintenance, okay. Predictive maintenance, scheduled maintenance, breakdown maintenance. That is not a type of the standard of classification of maintenance. This is also not according reliability centered maintenance. Is not a type of maintenance at all. Below are the maintenance types. That's wrong. So you will find the net or the LinkedIn or the media in general full of posts that everyone classifies maintenance as he likes, and unfortunately most of these are maintenance professionals, and many of them are certified as well. As well, the misconception number 4, that there is no standard definition for maintenance types. Everyone can give any type of maintenance definition, which is not according to standard, as you can see here. As you can see, even if you go to the Google and you ask what is the preventive maintenance, you will get a certain definition which is not matching the standard. And if you ask in another way for the same thing, what is preventive maintenance, you will get another definition, which both of them are not matching the standard. So you shouldn't rely on the net at all, because it will give you misleading information, non-standard information about the maintenance. Depends on sites, and these sites are not strict about their definitions and following their the standards. Here another definition, here another. There are thousands of different definitions of maintenance within the media and the net, and if you follow them, you will be lost. So what does the standard say? We need now to refer to the standards. Let's see what the standard definition of the maintenance types. This is the standard 13306 2017, and is classifying the maintenance into these types, as you can see here. There is a corrective maintenance, there is a preventive maintenance, and there is improvement maintenance. So we have 3 main types of maintenance. The others are subtypes of the main types. Okay, so actually we have 3 main types of maintenance: corrective maintenance, preventive maintenance, and improvement maintenance. So and as you can see here, I have already copied the definitions from the standard for you as a reference, so you can see the standard definition for each type of maintenance. So this maintenance here, no change of intrinsic dependability of characteristics. So it's corrective maintenance and preventive maintenance, which are the most popular one and the ones I'm going to focus on in this webinar. And there is an improvement maintenance, which is a change intrinsic dependability characteristics, and this is not in my focus now. And my focus now in the wrong definitions and wrong understanding of many things about these types of maintenance. So as you can see here, the corrective maintenance and preventive maintenance, it says here before failure and here after fault. So they are very specific. Failure has a definition, fault has a definition. Failure is what? Failure is an event, fault is a state. Now, before the asset fails, it goes to, it's like you can see here, we can understand this from this explaining. The failure, the asset is operating and then it fails down, and it becomes now in the fault state, and until it is repaired again and is working again back. So before the failure, we are doing PM. After the fault happened, the state, we are doing CM. And when it works back again, we do PM. Think of it like this one. Before that car crashed, so it was working fine, and then when it crashed, this is a failure. Okay, so before this failure, it was working, and then it failed, and now it is in a faulty state, and now it's a faulty state until it will be repaired and working back again. So that is the idea from before failure and after fault. So as you can see here, before failure, we do preventive maintenance. After fault, we do corrective maintenance. And preventive maintenance is two types, main types: predetermined maintenance and condition-based maintenance. And a branch of the condition-based maintenance is the predictive maintenance. This, and this are the most famous types of maintenance, and most misconceptions are about them. So the preventive maintenance, now that is a new definition for the preventive maintenance, that it is including the predetermined maintenance. That was the old definition of the preventive maintenance. This one was here before. That, as we'll see later on. Okay, so what's predetermined maintenance? 7.2. What is 7.2? Predetermined maintenance. Okay, first, preventive maintenance is what? Maintenance carried out intended to assess and or mitigate degradation and reduce the probability of failure of an item. So here it gives you the purpose of the preventive maintenance. It didn't say that it is done on predetermined intervals or based on condition or whatever. No, it gives you that the purpose or the objective of the preventive maintenance. That's why it is including the fixed intervals and the condition based, because both of them, their objective is to prevent the failure. Okay, so this classification is by purpose or by objective. So predetermined maintenance definition, or that is a predetermined maintenance, preventive maintenance carried out in accordance with established intervals of time or number of units of use, but without previous condition investigation. And the condition-based maintenance is preventive maintenance, which include assessment of physical conditions, analysis, and the possible ensuring maintenance actions. And then the predictive maintenance is what? Is condition-based maintenance. Predictive maintenance is a condition-based maintenance, but it is not the condition-based. It is condition-based maintenance carried out following a forecast derived from the repeated analysis or unknown characteristics and evaluation of the significant parameters of the degradation of the item. So predictive maintenance is a branch from the condition-based maintenance, but they are not equal. If they were equal, wouldn't be defined as two different types of maintenance. So okay, that's before the failure. After the fault, we do what? We do corrective maintenance. And this corrective maintenance is two types: either to be deferred or immediate. Immediate, that is the emergency, okay, that you should do it immediately now. Deferred can be delayed, can be done later on, and these are the definitions here for the immediate corrective maintenance and the deferred corrective maintenance. Okay, we will go further about details about these ones. So this is the emergency, and this is from the deferred corrective maintenance. Can come from where? Can come from breakdown or emergency that will be deferred, will not be urgent. Okay, and from PM and from run to fail as well, as we will see later on. Okay, so the other part of the standard classification for maintenance is that the maintenance is classified by scheduled and unscheduled. Okay, And you'll notice here that scheduled and unscheduled, this is not what we used to have. What we used to have is planned and unplanned. Now you have scheduled and unscheduled. Someone will say, okay, scheduled and unscheduled, same, is planned and unplanned. No, they are not same. They are very accurate in using the terms. Okay, so scheduled and unscheduled doesn't mean planned and unplanned. They are different. Okay, so let's discover this. So scheduled maintenance, that's scheduled maintenance, either to be predetermined maintenance. This is the fixed interval preventive maintenance, or the old definition of the preventive maintenance. Here, the condition-based maintenance and the deferred corrective maintenance. Okay. So scheduled maintenance, preventive maintenance without observation, that's without condition monitoring, which is depending on the time or fixed intervals only, not the condition. This preventive maintenance with observation based on the condition of the asset. Here is the corrective maintenance, deferred corrective maintenance. The maintenance it's not urgent and done according to a certain schedule and a certain time. Okay. Unscheduled maintenance includes immediately after fault detection, which immediate corrective maintenance, that's unscheduled. And the opportunistic maintenance, this type is new to many of us, okay? Opportunistic maintenance means what? Includes preventive or deferred corrective. That will be done when opportunity allows, okay? So why they said scheduled and unscheduled instead of planned and unplanned, okay? Because of this type of maintenance, opportunistic maintenance. Opportunistic maintenance, we do maintenance when there is an opportunity, and it will include preventive or deferred corrective. The preventive maintenance is definitely planned maintenance, okay? And the deferred corrective maintenance is also planned and scheduled maintenance. So they didn't say here unplanned, because here there is planned maintenance, preventive maintenance. There is an asset that has had a failure and a faulty state now, and we need to make some maintenance on that asset. At the same time, I can do some preventive maintenance, which it was not scheduled for that time. So that's why it is unscheduled for this time, but definitely is planned, because preventive maintenance is planned. And that's why they didn't say unplanned, because they couldn't say this, because the opportunistic maintenance has part which is planned, which is a preventive maintenance. That's why they used unscheduled instead of unplanned, okay? And immediate corrective maintenance as well is unscheduled, unplanned and unscheduled, of course, okay? And this type here is scheduled. All of this work is planned and scheduled. We should know that the scheduling coming after planning. So planning comes first and scheduling comes after planning. Okay, so this immediate corrective maintenance will be emergency maintenance. This one, deferred corrective maintenance, comes from delayed corrective maintenance, not emergency, not urgent work. And it will come from the planned work, like from the PM, preventive maintenance, and like coming from run to fail, and as we will see in detail later, okay? So, are there many maintenance classifications and types, and are they just names, as was mentioned before in the misconceptions? So yes, there will be many maintenance types and classifications if you don't refer to the standard. But and this is an evidence that you need that standard to avoid being lost. If you don't refer to the standard, you find hundreds of classifications of maintenance and many types of maintenance. Everyone is defining maintenance as he likes and give you different definition, and you will be lost between these classifications and types of maintenance. That's why we need to refer to the standard to avoid this mess, okay? So according to the standard, is officially classified into two main types, either by maintenance type, as you can see here, corrective, preventive, improvement, that's by maintenance type, or by scheduling, scheduled and unscheduled, scheduled and unscheduled, and everyone has its own subcategories. Okay, the following classifications, while widely used, not part of the standard at all. Risk-based maintenance is not a classified maintenance type or classification. Reliability-centered maintenance is not at all a maintenance type or classification of maintenance. Total productive maintenance as well is not. Run or shutdown maintenance is not a classification of maintenance. Soft services or hard services is not a classification of maintenance. Generational classification like industry 1, industry 2, 3, or 4, maintenance 1, maintenance 2, maintenance 3, maintenance 4. In that, the standard doesn't classify maintenance in such classifications at all. So using non-standard classification can lead to what? Can lead to inconsistent maintenance terminology across organizations. Everyone he will use his own terminology and his own understanding or referring to whatever classification as he reads. So it will be a mess. Okay, difficulties in compliance and auditing. If you want to be complying to standards and complying to certifications and requirements, you will not be able to because you don't have a standard type of classification to refer to as an organization. Problems when comparing maintenance performance between different facilities because you don't refer to the same standard. There is no standardized type of maintenance you compare based on. Challenges in standardizing maintenance procedures. Confusion when training maintenance personnel. What you are going to teach them. Everyone will tell them what he believes, what he thinks, and he will be lost. Complications in maintenance documentation and reporting as well. Okay, so let's take an example of a manufacturing plant. Our classification type just names. A manufacturing plant has several assets that require regular maintenance. The maintenance team often use different terms to describe similar activities. But without standardized or standard classification terminology usage, for example, one technician refers to routine checks as preventive maintenance, another calls them scheduled maintenance, a third technician categorizes run to fail as, which is deferred corrective maintenance, as reactive maintenance, and this is not standardized terminology. Okay, communication, miscommunications occurs during meetings, leading to unnecessary downtime due to duplicated or overlooked tasks. Inefficiencies arise when management misunderstands logs because the logs will be written in different language. Everyone reports the log as he likes according to his definition, leading to incorrect decisions like unnecessary purchases or overhauls. Training, new hires face challenges understanding processes, which prolongs onboarding and reduces their effectiveness. When everything is standardized, all maintenance activities are categorized clearly. For example, preventive maintenance, corrective maintenance, there is standard definition for the maintenance activities, and team members use the same terminology, reducing confusion and improving collaboration. Management can allocate resources accurately. New employees can learn quickly about the maintenance. Okay, so adhering to standard classification system maintenance ensures clarity, improves efficiency, and ultimately contributes to better resource management and operational performance in environments where precise and effective maintenance is critical. Number 5, misconception, CBM and predictive maintenance are the same. Condition-based maintenance and predictive maintenance are the same. One of the persons who is famous on the LinkedIn, and he published the following. Many people think that condition-based maintenance and predictive maintenance are two different needs, but in reality they are the same. No, they are not the same. Condition-based maintenance has a definition in the standard different than the predictive maintenance definition. If they were the same thing, we call them condition-based maintenance and that's it, or predictive maintenance and that's it. No, everyone has its own definition and its own technique. Okay, and there is a put for you a comparison table between both of them. You can refer to this to know what are the differences between them. For example, for predictive maintenance is very early detection of defects 60 to 90 days in advance, while in the condition-based maintenance, it's a real-time conditions. You go check, measure now, and compare it with the baselines. If there is exceeding the thresholds, then you want to do whatever required as a maintenance. And if they are within the thresholds, you don't do anything. While the predictive maintenance is depending on the statistics and the models and the formulas, calculations, and the previous readings and the predictions. So it's different in the technique completely. So type of maintenance, they are both of them before the failure or the breakdown. Here is using formulas and calculations and sensors. Here there is no formulas and calculations at all. Okay, that's real-time checking, and that's it. Okay, so there are differences between them as well. The predictive maintenance is two types: is condition-based, which is based on the previous readings and measurements, and statistical based on previous failures happen to this asset. These done through certain models, and this is done through certain models. And this technique is different than the condition-based maintenance. So they are different. So condition-based maintenance and predictive maintenance are not the same. Number 6, preventive maintenance is time-based only. That was the old definition of the preventive maintenance, as I said before. As in the past, maintenance was planned and unplanned. In the planned was PM. What's PM? PM is different than condition-based maintenance, and it's different than the predictive maintenance. PM is time-based, fixed intervals, condition-based, and predictive. Now in the new, in the standard, the preventive maintenance now is including the condition-based maintenance and the predictive maintenance. So this one has come up here. PM, sorry, the PM, the preventive maintenance has become, imagine that planned here became preventive maintenance. Preventive maintenance became including the time-based, the condition-based, and the predictive. And this one came under this one. The predictive maintenance now is under the condition-based. So before, in the past, the fixed interval maintenance was a preventive maintenance. Now, no, it became down here, and the preventive maintenance will become what is the purpose, the objective of doing preventive maintenance, whether it is predetermined or condition-based or predictive, because all of them are trying to prevent the failure before it happens. So that become the purpose here. Okay. So now you know that if you live in the past, you will still understanding this understanding, okay, which is now changed to this one. This gives you an indication that you need always to update yourself regarding the new classification by the standard. So if you don't follow the classification, you update yourself, and you are, for example, in a very sensitive industry, you will be expose yourself to, for example, maybe fines or penalties or legal issues because you are not updating your documentation, your practices according to the new standard requirements. Okay. Competitive disadvantages: organizations can't benchmark performance against industry best practices without adopting the standard, resulting in competitive disadvantages. Modern maintenance practices are essential for operational efficiency, cost reduction and performance improvement, missed the opportunities for improvement. The updated standard enables continuous improvement in maintenance. By not adopting it, organizations miss out on optimizing their operations and achieving further efficiency. So you need always to refer to standard and see the new updates and implement the updates in your system. Now, another misconception is that the corrective maintenance is only reactive or unplanned. This is widely spread misconception in the maintenance field. Many maintenance professionals, they are following such misleading information on the media, on the websites or whatever, that you can hear for corrective maintenance is a reactive approach only. They mention that it is always reactive. Yes, corrective maintenance has part of it reactive, but it has also a part of it which is not reactive. So the common belief is that corrective maintenance is entirely reactive, addressing failures only after they occur. But the reality, corrective maintenance, as defined by the standards, includes unscheduled, which is reactive, that's part of it, and scheduled, which is including proactive actions. We can see here the standard, as we can see here, there is unscheduled maintenance, immediate corrective maintenance. Yes, this is reactive, but we have here deferred scheduled maintenance, which includes part of it is proactive, as we will see. So what happens in the plant? In the plant, we have unplanned corrective maintenance work, which is reactive, after fault happens. Okay, what will happen? We'll have, for example, immediate emergency unscheduled maintenance. That's emergency, immediate, as is classified by the standard. Immediate corrective maintenance. That's immediate corrective maintenance. Comes from where? From the emergency that happens on site. That's unscheduled. Okay, and as well, if there is a breakdown happens on site, but it's not immediate, it can be deferred, can be repaired later on, but it's still, of course, reactive. That is the reactive part of the corrective maintenance. Where this will go in the big picture, that's the big picture of the corrective maintenance. Okay, so you have immediate corrective maintenance, unscheduled after fault, as we said. This is the one here. That's this is the one will come here. That's immediate corrective maintenance as classified by the standard. For the other type, which is deferred corrective maintenance, this maintenance is not urgent as this one, so it will be done later on. Okay, but it's still reactive. And this is most of the unplanned corrective maintenance, because the emergency is not most of what you have. What you have are failures or breakdowns that needs to be repaired or corrected, but after planning and scheduling. So you do planning and scheduling, and it will be the scheduled corrective maintenance. Okay, that is the scheduled corrective maintenance. So this will come here, this will come here, and this is the reactive part of the that is the reactive part of the corrective maintenance. What about the other part of the corrective maintenance, which is the deferred corrective maintenance? This is under deferred corrective maintenance, there is another part. That the other part, which is proactive from corrective maintenance, is under the scheduled maintenance. Coming from where? Coming from PM. While you are doing preventive maintenance, you can discover things that will escalate to be a failure. So you raise a corrective maintenance work order. That corrective maintenance work order will be a planned corrective maintenance work order, not unplanned. So it's proactive, not reactive. Because why? You are doing preventive work and you discover it before it escalates to failure. That's why it's proactive, not reactive. Also from run to fail. From run to fail. Run to fail is a maintenance strategy. It's not reactive, as stated by Mr. Ramesh Gulati in his book, Maintenance and Reliability Best Practices by Mr. Ramesh Gulati. Okay, he said that the run to fail is a maintenance strategy when it is done deliberately for the non-critical assets that their failure will have no impact on safety or environment or any or in production or high cost, or it has no impact at all. So why I bother myself and do a maintenance program for such assets? We leave them run until they fail, and then we repair them or replace them as required. We have a plan for this. We have the parts for this. Our people know how to deal with this type of failure. So we are planned to correct it when it is done. So this part is a proactive part of the corrective maintenance. So as clearly shown here, the corrective maintenance is not all reactive. Big part of it, of course, is reactive, and the other part is proactive. Here is if this, according to the maintenance best practices, reliability best practices as per SMRP, that the corrective maintenance should be 55% of the total workload in your company, as we will see later on. Okay, and this is most of your backlog. That is the corrective maintenance, because as you can see here, it is 55 of your total workload. And 50% of this should come from the PM. PM here means what? As according to the standard, it is condition-based maintenance and the predetermined maintenance. These types of two maintenance. PM is not anymore the predetermined maintenance only. That predetermined maintenance and condition-based maintenance, which has the predictive maintenance under it. Okay, so 50% of the CM will come from PM, and it will be considered as proactive, not reactive. So you can see here some examples from the net, but this is correct one, not the wrong one. It says that the corrective maintenance can demonstrate these differences here. The run to failure, we spoke about run to failure corrective maintenance, is a proactive one, and the planned corrective maintenance, this type of maintenance often goes hand in hand with the preventive maintenance routines. When you find by the inspection some things that need to be corrected, then these are now planned corrective maintenance. Unplanned corrective maintenance, something else which occurs when there is no set preventive maintenance plan in place. So what happens? You do preventive maintenance, you see some issues that need to be corrected. You fast check it requires fast fixing or not. If it requires fast fixing, you will do it on site while you are doing the PM. If not, it will be created work order. That work order will be planned corrective maintenance. So proactive maintenance, as defined as well by Mr. Ramesh Gulati, is in match with the definition of the SMRP best practices. Proactive maintenance can be defined as all the work tasks completed to avoid failures or to identify defects that could lead to failures. Okay, that includes the corrective maintenance raised from the PM. So corrective maintenance is classified by him as work can be further classified into scheduled. So corrective maintenance can be scheduled, coming from major reports or projects, and reactive means that there is scheduled, which is proactive, and reactive part of the corrective maintenance. So corrective maintenance is both. Okay, here from the SAP manual, okay, it says that the corrective maintenance can improve asset health and performance in situations when planned maintenance occurs. When preventive maintenance tasks identify potential faults, then in this case you will raise a corrective maintenance, and this corrective maintenance will be planned. When condition-based monitoring finds machine anomalies that signal potential failure, that will be as well a planned corrective maintenance, and so on. So misconception number 8, maintenance standards does not cover all types of maintenance. Someone wrote that this standard is not very helpful with the classification, its classification. I strongly believe that maintenance styles should be classified based on their failure mode characteristics, and so we can assign maintenance types based on those characteristics. Okay, so he's claiming that the maintenance types in the standard are not enough. Why? He says, for example, where is risk-based maintenance in that standard? Okay, what's risk-based maintenance? What is doing? Is doing inspection or test. Okay, who said that this is not in the standard? Who said this? The standard defined as well what we call it maintenance activities, not only maintenance types, but maintenance activities. Under the maintenance activities, there are before detection of failure and after detection of fault, as we said before. So the preventive activity has many activities we are doing under the preventive. We will not convert every one of these activities to be what? To be a maintenance type. That's not logic, okay? So what you are looking for is an inspection. That's already here. Risk-based maintenance is under the preventive activity, and detect degradation, and here diagnosis of degradation. You can do an inspection non-invasive while monitoring, while the asset is running, or internal inspection of the asset to do what? Too often used of pressurized equipment and can be used for pressure relief valves. So can be internal inspection to determine when will be the next inspection and to check the condition of the asset internally. So it is there as maintenance activity. We will not convert every maintenance activity to be a maintenance type. Yani, for example, in the maintenance activities, we do cleaning, we do lubrication. We will not give the cleaning maintenance type called cleaning or lubrication maintenance type or replacement maintenance type. No. These are activities done under the maintenance types. Okay. So number 9, misconception number 9, that this standard is for Europe only. Standard we don't have to follow. Okay, that is a standard, a European standard. And okay, what about the ISO 14224? ISO 14224 is an international standard. It's not a European standard only, and it had made a reference to this standard. Okay, but this one is 2010 and this is one 2017, because this one actually was issued 2016 before this one being issued 2017. So this standard, the international standard, is referring to the this standard, the European standard. So both of them are widely used, and there is no excuse here. Okay, so in the standard, the way it says what deferred maintenance should also include planned corrective maintenance. So you see here, corrective maintenance can be planned, not only reactive. Planned, where run to failure is the chosen failure management strategy. So that's run to fail is a strategy as indicated as or stated by the standard. Okay, so standard defines what's proactive work. Okay, so run to fail, as we said before, by Mr. Ramesh Gulati, is here identified that run to fail is a maintenance strategy on this basis. Okay, fine. So beyond the maintenance types, the deeper problem with maintenance types classifications. Okay, it's not about only the classification, this preventive or predictive or corrective or whatever. This is not, that's not the main problem. The main problem is the systemic impact. And the maintenance actually is a system. and everything within that system depends on each other. So, and all of the maintenance system is depending on the maintenance types, as we will see later on. So any issue in any part of this system will impact the other parts. Dangers of subjective perspectives, classifying maintenance types based on personal views is fundamentally superficial. Such approach lacks scientific accuracy and systematic understanding. We should be scientific, refer to scientific methodology, which is based on standardization. The risk of randomness, and everybody is referring to his opinion, his beliefs, his understanding. This mindset promotes chaotic approach to maintenance activities, creates dangerous practice where individual standards replace standardized protocols, leads to inconsistent approaches, not just in maintenance, but potentially extending to broader organizational and personal practice, because it's a mindset. If the people used to be random, using whatever without referring to standard, then this will be, or not only be in maintenance, there will be a lifestyle. Okay, so the key takeaway here: the maintenance classifications are not trivial; they are strategic foundations. Okay, so cascading impact of maintenance misconception. What is the problem now? What about this? So initial problem is lack of understanding or lack of standardized understanding. Okay, now this problem spreads misconceptions about maintenance fundamentals. Everyone understanding different understanding from the other, and this creates confusion and widens the existing knowledge gaps, promotes non-scientific, non-engineering approaches to maintenance. We are engineers. Engineers always refer to standards, to calculations, to scientific methodology, not to opinions. No opinions, no beliefs, no backgrounds. Things like this shouldn't be. Or it leads to fragmented and random maintenance practices, of course. Okay, so this knowledge gap creates direct operational impacts. For example, wrong selection of maintenance strategies. Improper, if I don't know what are the maintenance types, so my maintenance strategy will be wrong. Improper implementation of maintenance types, poor decision making in maintenance planning, ineffective resource allocation. So these issues then lead to serious consequences. Like what? Like reduced asset reliability and increased breakdowns. If I use the wrong maintenance type and the wrong maintenance strategy, then my assets will be definitely affected by this wrong selection. Higher operational costs and wasted resources, compromised safety and compliance risks, difficulty measuring and improving performance. The solution for these problems is what? Is to standardize. Standardized maintenance policy must adapt maintenance types according to standard, ensures organization-wide common understanding, promotes scientific engineering-based approach, and creates foundation for structured improvement. So what is built on maintenance types? Let's see, because some people take this light. It's what is the problem? Maintenance type is just a maintenance type. I will name it as I like. No, it is not like this. This is as I imagine the maintenance from my point of view, that the maintenance is like a pyramid, like a system that is built on each other. So the foundation is your asset register, while you have the location hierarchy, the asset criticality, and the asset technical details. Based on this, you have to define your maintenance policy. In the maintenance policy, you define your maintenance types that you are going to use for your company. Maintenance policy is, as we will see, a general framework for your maintenance. Okay, and then based on the maintenance policy and the maintenance types stated in your maintenance policy, you will decide your maintenance strategy for your asset and select these strategies, resource planning and budget allocation, and this will be reflected through and managed through the CMMS system that you will have the PM program inside, work order classification, inventory and contract management, history analysis and failure tracking. And here you will do work management through the CMMS system, and the work management will include the planning and scheduling, resource allocation, backlog management, and so on. And then at the end, you have to manage your performance through KPIs and benchmarking and the strategy effectiveness and continuous improvement. So you can see here that the system, all things are built on each other, depend on each other. All of these things are depending on your maintenance policy. Okay, so the maintenance policy states the maintenance types and their definition. So what is the maintenance policy? It's a comprehensive set of guidelines that defines how an organization will maintain its assets. That policy, in this policy, you have to define your maintenance types in your company, so that it will be a reference to all the maintenance professionals in that company, so that all speak the same language, we are all standardized, we are applying the same terminology everywhere, otherwise it will be a mess. Okay, so the benefits of and importance: operational benefits, reduced equipment downtime, extended asset lifespan, improved safety conditions, significant cost saving, and enhanced operational efficiency. The communication and knowledge benefit, this is very important: standardized maintenance terminology, that's very important, better data collection and analysis, simplified training and knowledge transfer, clear communication across departments, because we all use the same terminology. Compliance benefits, demonstrates commitments to best practices, which supports regulatory compliance, aligns with industry standards. Okay, so the example of maintenance policy, that's our maintenance policy is characterized by safety, efficiency, quality, and flexibility, and so on. And we'll see here that a maintenance technician should know and understand the maintenance terminology of the European standard, this one, and have the ability to use them in practice. So maintenance work types distribution, okay, that will be according to SMRP best practices. They have done, they've made a key performance indicator that shows you that all of your work is 100%, and this has to be distributed as follows: improvement and modification work 10 to 15%, structured work identification 30%, which is condition-based maintenance, predictive maintenance, and preventive maintenance, that's the PM. This is structured according to the maintenance standard. So this is the improvement, this is the PM, and this is a corrective. You can see here structured 30%, and you have here 10 to 15, then you have 40 to 45. Then if 40 to 45 is planned, so corrective maintenance 55 is unplanned, this seems to be reactive. No, wait, 50% of the 55 comes from the PM, okay, from this one, comes from structured work. So this 50% will be planned, not unplanned. Okay, 5% only corrective work, not from structured work, which is unplanned, which includes the emergency and so on. Okay, so here they define the SMRP, this KPI, work types and associated metrics are structured according to the standard. You have improvement work, you have PM work, you have corrective work. This is the standard. Okay. And then the purpose enables analysis of several factors, including the effectiveness of the preventive and predictive maintenance program. How can we measure our effectiveness of PM program? Through the corrective maintenance, as we will see later. Okay, so if effectiveness of work order management process, the effectiveness of the work management process, and the degree of which organization updates with proactive philosophy. Okay, so structured work identification is this one: predictive, condition-based, and preventive. The corrective maintenance or corrective work from structured work, this is what identified through preventive or predictive maintenance, which completed prior to failure, that is planned. And this one is the unplanned. Okay, so I wrote an article about how to implement this KPI in your CMMS system. You can refer to this article. It tells you in detail how to apply this in your CMMS system. Okay, so establish asset maintenance strategy based on standardized maintenance type. So you have a maintenance policy which tells you what are the types of maintenance you are going to use. Here, for example, if you have developing a maintenance strategy for a manufacturing facility, scenario manufacturing facility with critical equipment, objectives to minimize downtime, extend equipment lifespan, optimize maintenance costs. So what should I do? Number one, assess the current maintenance practices, and then I apply the standard classification. I use the predetermined maintenance, which is preventive maintenance, fixed interval, the condition-based maintenance, the predictive maintenance, and for the immediate corrective maintenance, I have to have a protocol, business process for this. And for the deferred corrective maintenance, I'm using the maintenance types, and I have to evaluate afterwards and adjust my maintenance strategy and through the key performance indicators, and I do continuous improvement. One of the things can help me choose my maintenance strategy. Of course, my maintenance strategy will be based on failure mode effect analysis, RCM, whatever the technique. But here it tells you that in general, if you have, according to this matrix, if you have ease of monitoring is low and the cost of failure is low, then you will leave it run to fail. If it is this higher, then you can use time-based here, and you can use condition-based in this area, and predictive maintenance is the highest technique. It's, monitoring is high, and the cost of failure is high. Then use this for your critical assets. Okay. Number four, how to reflect. We said that everything is depending on each other in the system. Now, how to reflect that the maintenance types in your, and this classification of the standard in your CMMS system. You have the work order, and you have your work order type. In the work order type, you can use these types already, or not you can, you must use these types. We already found in the standard. You have the corrective, you have the predetermined, you have the condition-based maintenance, you have the predictive maintenance, and you have the improvement. These are the maintenance types according to the standard. We have modification in the standard, but this modification is not a type of maintenance. Modification is not a maintenance action. So these are only the maintenance types. What is this? Why it is here? It's a work order type. Work order type, not necessarily to be maintenance type. So, okay, so you have modification, you have standing or blanket work order, you have project work order, you have other types of work orders that can come under the type. But here you have to reflect your maintenance types as they are. Now, corrective maintenance can be immediate or deferred. That will be shown in the work order priority. Okay, so you are not in the corrective maintenance say immediate corrective and deferred corrective as types. No, it will be corrective, but immediate or deferred, this depending on the action will be taken on site, which will be reflected in the work order priority. In the work order status, it shows if it is scheduled or deferred, and planned later on will be done. Scheduled, deferred, and it will be planned first and then scheduled afterwards. Okay, action by planner and scheduler. So deferred or scheduled will be done during the work order status. Shutdown or work or not shutdown work is not a classification here, but it is a flag in the system. This corrective maintenance or preventive maintenance, whatever, will be done during a shutdown or not. This is a shutdown flag, and there is a type of shutdown. This shutdown is unit shutdown, equipment shutdown, train shutdown, total shutdown, the types of shutdown. And you can use outage code for the work orders that will have a shutdown as well. CM source, condition monitor, corrective maintenance source, from where the corrective maintenance comes. It comes from predetermined maintenance, or from condition-based maintenance, or from predictive maintenance, or from operations or from others. That's important to calculate the KPI for the which we mentioned before, from where you captured this corrective maintenance. If it comes from predetermined maintenance, will be planned. From CPM will be planned. From PDM will be planned. From operations will be unplanned. And from others it will be unplanned as well. So if it comes from PM, the corrective maintenance will be planned. That's how this is reflected in the system. So you can see here that the work order as well is depending on the classification of the standard. The workflow of the work orders as well will be depending on the standard. Okay, as stated here in the maintenance reliability best practice book by Mr. Ramesh Gulati, he showed here the workflow in the CMMS, how it will look like. Okay, so reactive work or breakdown emergency work will go directly to work execution because there is no time for planning and scheduling. It will go immediately there. So new work from PM or condition-based maintenance will go through planning and scheduling and then will be executed. Planned work, which is the PM because it's already planned and in the system, will go directly for scheduling. But I added to this because it's important as well, is this is the immediate corrective maintenance is coming from the reactive work, okay? And here the deferred corrective maintenance will go to planning. If it is not immediate, it's not urgent, then it will be deferred. It will go to them planning and the scheduling, and the work request as well. Other work requests will go to planning and scheduling coming from operations and from other sides as well. It would go to the planning and the scheduling. This is the same here stated in the Mobius Institute work management model shown here. The same thing is here, is that the break-in work, which is the immediate work, will go to direct for job execution. The normal work request or the work coming from the PM will go directly to scheduling, and the work request will coming like this one, other request or deferred CM will go to the process of planning and scheduling and be implemented. And here is mentioning what is corrective maintenance generated from PM inspections, routine operational request, and routine service requirements. Okay, these activities make up the maintenance backlog and should be planned and scheduled in advance. So most of your backlog coming from the CM, not PM, as somebody thinks. Okay. Now it will be reflected as well in the scheduling. You can see when we do weekly scheduling for our activities for the next week, we always keep 30% of the next week. This is week 1, 2, 3, 4. The planner is and scheduler are scheduling for the next coming weeks, and they make sure that every week 30% of it is booked for the PM predictive maintenance according to the best practices metric I showed you before. Okay, and the others will be filled with other work. The same thing is stated here by Mr. Rick Smith and upkeep and world-class maintenance. In their explanation here, they said that in scheduling you have ready work order list. From this you select 30% are what are reliability schedule PM program, PM. And then you start adding to it from maintenance and operations until the schedule is prepared. And as you can see here, PM 30% according to the best practices and the standard. Okay, so these are 30% as you can see here. So the SMRP best practices shows what is the proactive work. Proactive work according to the SMRP best practices, it shows that they could include the routine, preventive, and predictive maintenance activities and corrective work tasks identified from them, from preventive and predictive. And the formula for the calculation shows the work completed on preventive and predictive and corrective work identified from preventive and predictive work orders as well. So not all the corrective is reactive. No, here it says that the work coming from preventive and predictive is proactive. And they wrote this in that part. Okay, they said proactive maintenance contains the standard, and they refer to the standard definition of preventive maintenance plus the part of corrective maintenance tasks originating from findings during predictive maintenance and so on. So proactive work includes predictive condition-based maintenance, preventive and corrective work structured from identified work identification. So CM coming from PM and predictive maintenance is proactive. Okay, and this give you a calculation here for if you have the organization, your plan to work 1,000 hours and 150 hours with preventive, 100 hours was working on predictive, 400 hours were on corrective maintenance from preventive and predictive. How can calculate? You calculate this way and you will get the proactive work 65%, because here it sums 150, 100, and 400. They are the 400 is calculated part of the proactive work. Now, if you do a wrong calculation and you don't consider that work coming from CM is corrective, is proactive, you consider it reactive, then what will be the percentage of your proactive work will be 25%. That's very dramatic change and significantly change, and that's wrong calculation because you didn't consider the work done coming from the corrective maintenance as corrective maintenance during preventive maintenance is proactive work. So best in class value, you have greater than 80% based on standard maintenance types and distribution. Now, reactive work is what? Reactive work is maintenance that breaks into the weekly schedule. Okay, that is the immediate, the urgent work. Includes emergency breakdown and unplanned work. Reactive portion of the corrective work. Okay, so that is a sample calculation, and best in class less than 10%. Okay. Performance budget, PM effectiveness. How we measure our preventive maintenance effectiveness? We measure our preventive maintenance effectiveness through this formula: that number of PM and predictive maintenance corrective work orders necessary over the numbers of PM predictive maintenance corrective work orders rating. So it shows you that corrective maintenance coming from the PM and predictive maintenance will be the vehicle by which the effectiveness of the planned maintenance is monitored. Why? Because your PM and predictive maintenance, the core objective of them is to catch the things before they escalate to failures. If your preventive maintenance program is effective, then it will capture all the faults before the defects before they escalate to failures. So that's effective. If your system is not effective, so the PM will not be capturing your PM program will not be capturing anything. If it's capturing too many things, means that you have problems, you have defects not to be eliminated. If it doesn't capture anything, means your PM program is not effective. You do the PM to make the inspections and capture the signs of failures and correct them before they escalate to failures. So what's beyond the maintenance types? Your gateway to global excellence. Now, why international standards matter? Because global benchmarking, aligning your maintenance types with international standards allows you to compare your performance against world-class maintenance organizations. It will show you, are you proactive or reactive, according to the structure we already explained. It will show you a strategy and workflow, structuring your maintenance framework based on international standards sets the foundation for maintenance strategy development, work management and workflow design, effective planning and scheduling. Performance measurement used standardized KPIs to track improved performance, audits, validation of maintenance performance and compliance with the standards, continuous improvements aligned with best practices to drive sustained improvements in reliability and maintainability. So impact on international certification. If you don't follow the standard, there is a big chance that you will not be certified organization for example, ISO 55000 or for any ISO to be implemented, because you have inconsistent practices, you have poor benchmarking, you have unstructured processes, you have non-compliant documentation, and you have missed the requirements. Okay, what is this impact on the business? You have limited access to global markets. You have reduced competitive advantage. You have questionable reliability practices, harder to prove capability, lost business opportunities. The real cost of non-standard approaches: lost certification opportunities, increased audit complexity, higher compliance costs, reduced market access, limited professional development. So it's your choice to be connected or isolated. Connected as organization, connected by what? By following the standards. You will have access to global best practices, valid performance comparisons, clear improvement paths, industry standard processes, proven optimization methods. If you don't follow the standards, they follow your own standard, your own terminology, then you have limited to internal knowledge, no valid external comparisons, uncertain improvement direction, non-standard processes, and unvalidated methods. So lastly, my key message to you: using your own maintenance terminology is like speaking a language only you understand. You might know what you mean, but you can't participate in the global conversation about excellence. Action points: what's required from you to do is to adapt standard classifications, enable meaningful benchmarking, access global best practices, validate performance levels, drive continuous improvement, and stop, please, spreading maintenance misconceptions. The bottom line: standards connect you to excellence, non-standard approaches isolate you, global benchmarking needs a common language, excellence requires external validation, and improvement needs comparison. So please follow the standard classification and maintenance types as explained in this webinar. I hope that you benefited from this webinar. I'm sorry for taking some long time, but it was very important to give the whole idea as should be. And actually, that was very brief as well. We can speak later on more details on this subject. Thank you very much for following me. And now I hand over to you for a question and answer session. Thank you very much. Thank you very much.
All right, everyone, due to time constraints, please place your questions in the question panel, and those will be sent for Ahmed to reach out to you individually to make sure that those questions have been answered. Thank you all for joining us. Thank you, Ahmed, for your awesome presentation. Keep an eye out for an email from us containing the on-demand version of this session and your certificate of attendance. We encourage you to share your certificate on LinkedIn and tag us at Mobius Connect. Before you leave, check out the Mobius Connect Live 2025 locations to see if we're visiting a city near you. We'd love to see you there. Please complete the form found in the chat to receive updates about your preferred location. You can use code WOW14 to get 50% off your pass. Also, if you're interested in engaging with other industry professionals or would like to participate on the industry's live feed and forums, please visit mobiusconnect.com to create your free profile and follow us on social media at Mobius Connect. Whether you're looking to share your insights, expand your reach, or build relationships, you can learn more about partnering with Mobius Connect by contacting us at info@mobiusconnect.com. And finally, be sure to join us for our next WOW presentation Coming up, that'll be tomorrow. We have Bearing Case Failure Study at 7 a.m. Eastern Time. If you'd like to sign up for more sessions, head over to our social media at Mobius Connect to see the full WOW agenda. Again, we hope to see you there. But until then, thank you again for joining us. Have a great day. Please stay safe, and we will see you next time.